Hello everybody in EL275. This is going to have to be our sensor quiz review as we had some challenges in lab, and I'm going to try to rip through this as fast as I can here. Okay, I'm going to start with question number one. An inductive prox is a switch that should be would be a good choice to sense cardboard boxes. That is a false statement because why? Inductive prox can only pick up metallic devices such as steel, stainless steel, copper, that sort of thing. Photo-wise can sense over 20 feet. That is a true statement. When a second push button is added to a machine, it is wired in parallel with the first, so either button will start the machine. It is if you think of it in the sense of or statement, if you can press this button or this button, it always puts those in parallel. Number four, a through beam photo eye needs two different units, transmitter and receiver, pointing it to each other. That is a true statement. We have a scenario where we have a one device transmitting the information, the other one receiving it. That receiving unit is the one that has the contacts in it to tell the PLC whether it's on or off. So that is also a true statement. The reed switch can be measured with an ohm meter. That is a true statement. A reed switch is essentially a device that is influenced by a magnetic field. As the magnet comes into play, it actually forces the metal strip to close the contact. So it's a very simple operation. A shielded inductive proximity switch has a greater sensing range than unshielded. I did not discuss shielded and unshielded in lab or lecture I don't think it was brought up, and I didn't discuss it. A shielded sensor is one that has the metallic, or it can't even be. I think there's metallic. I think they're all metallic. They have what they call the barrel of the switch itself is all the way up to the end of it, shielding it so it will not read the material that it's screwed into or that's holding it in place. A unshielded prox typically will have a cap on the top of it, like there's no threads on it, and that allows it to read out and around the sides of it. If we need more clarification on this, please bring it to my attention. We can certainly do that. Okay. Electronic sensors are more reliable. That is a true statement, just simply because why? They're solid state. There's no moving parts. Copper and steel are the same range as inductive prox. That is not a true statement. That is actually false. The more iron in the steel, there's more iron in steel, excuse me, than there is in copper. But so the copper will not trigger the inductive prox in the same range. A fork-type photo eye will be a great choice to sense the thickness of a part or a sheet. A fork-type photo eye is essentially all it does is read presence or not presence. So when you break the fork, when you have if you think of it as a U-type sensor, and you stick something in that U, it is when it would detect that something is present. So they're not used for depth or any of that. It's just presence or not presence. The schematic symbol for a normally open, or for a NO, is a normally open, held closed contact on a limit switch are the same. So the schematic symbol for a NO, a normally open, held open, and held closed contacts on those, and that's a false statement. They're not the same. It just puts it on the same. If you remember right, normally open, if you put the two terminals to draw two circles on the page, and then you draw the line below the circle on the right, that means that it's what? Normally open. Now, if it's normally open, held closed, that means that it's making contact with that second circle. If it is not, then it is not making contact with that circle. Number 11 is a photovoltaic type that has the longest sensing range. It is a through beam. It is B, so it gives you the through beam gives you the longest range in a sensor, in a photovoltaic sensor. Number 12, the difference between the set point vacuum and a reset point in the vacuum is A, the differential. The disadvantage the disadvantage to electronic sensors is most do not have, and I want to say this is a bad question, so I did not mark anyone's wrong whether you had A, B, C, or D on this one. So I think it's just a bad question. So I scratched this one, 13. And 14 as well. I don't like 14 either. It's a general rule is not a good way to ask a question, so I scratched that one as well. So 13 and 14 are scratched, so you get those points. Freebies for you, no problem there. So that brings us to 15. 15 is C. The negative power. So remember, when we have an NPN, if you're feeding a positive input to a input card, right? It's got to have a negative to read through that card, to read that, to make that signal come on, to acknowledge that signal is on. So it's C, a negative voltage. 16 is D. The selection of sensors should be based on all of the above. 17, the capacitive proximity sensor would be a great sensor for use for all the above, E. 18, which of the following is an advantage of an electronic sensor? Electronic sensors, what is an advantage of electronic sensors? E, all the above, lower maintenance costs, long operating life, all that business. 19, the difference between on and off of a proximity switch is called what? And that is hysteresis. We didn't talk about that. I should have probably brought that up, but hysteresis is the true answer there. If you have some questions about that, I have a pretty good lecture on that doesn't take but a couple minutes, so we can talk about that as well. Number 20, the amount of time that it takes when a target enters the sensing range of a sensor and the system acknowledges a change in the sensor is called what? And that is response time, C. Okay, now a couple of diagrams here showing you real quick. The normally open, held, closed. Normally open, held, closed. Normally open, held, closed. That is it would look something like this. Normally open, when you think of normally open, it normally opens always underneath the terminal here. And normally open, held, close is being pressed against this terminal. So that is a screw up on my part. I'll correct that, get that nailed down. Next piece is this guy here. We have the two position selector switch with double pole, double throw. So double pole, right? So we have two pole and double throw, which means you have two pole on the top, two pole on the bottom. So that's what I was looking for there. So you flip it back and forth. It takes this contact from this location, and the same here, drops it from this location to this location. Form C contact. We talked about this a little bit in class. This is the style of contact that you do find in your ice cube relays. I think I actually had one student actually draw a complete layout of an ice cube relay, which was a little overkill, but this is all I was looking for. Is essentially what you're looking at is one common feed when it's in the off state, it feeds this normally closed state, and when it's in the on state, it feeds a normally open state. You would see a terminal, a wire going from each one of these terminals, and this would be in the common. So keep that one in mind. You will run into that again. I guarantee it. It is a very common contact configuration used in industry. It provides us a lot of solutions. I think everybody got the proximity switch right. I think that was a solid solution. I think everybody understood that the diamond indicates that it is a solid state device, and whether you show it as this contact or the like a limit switch style, that's either is fine. I think that's a solid solution there. The flow switch, a lot of students struggle with this one. This is that little flag indicating that the flow is passing through some line or pipe or something of that nature. And then normally closed is actually, again, this is wrong again. Jeez Louise, I am not on it today. Normally closed, right? We got normally closed. Normally closed is on top, right? Something like this. It should be something like this. Exactly like that, right? So the question was a normally closed flow switch. So a normally closed flow switch should look something like this. A normally closed held open would, of course, look something like this, if that was the case. But it is actually a normally closed flow switch. So even I screw up from time to time. So we'll get I'll get this corrected on my answer sheet and get these all graded out and back to you guys. So that is the review of the exam. If you want, I can certainly do a Zoom meeting with you, or we can take some time maybe before class and review some of this stuff too, if you really like to. Okay. Thank you for your time. Bye.